I've been invited here today to talk about MRLs. I've been working in the area for about 3 years now with the industry government MRL task force. By trade, I'm a canola pathologist and a wheat breeder, but I've worked in the multinational chemical industry since getting out of school. So I hope by the end of this talk I can answer 8 questions for you. I'm not going to cover what MRLs actually are and how they're developed. There might be a bit of education required there, but I think because I'm standing up in front of you, you must appreciate that they are an issue and they're becoming more important. But I hope to convey how they're being monitored globally, why they're more of an issue now than they have been before, what you as a producer can do on your farm to deal with MRL issues. I'm going to talk about what's being done already in some Canadian crops, talk about whether or not they've been an issue previously, tell you whether or not this is happening again, and obviously the answer to 6 is yes, based on 5. How much does it cost when we have an incident in Canada? So when there is an MRL incident, what does it cost an exporter? What does it cost the producer? And what does it cost the industry as a whole? And how can you, as a producer, become more involved in managing MRL issues? So hopefully by the end of this talk, you'll be able to answer these 8 questions for yourself. If not, I'm going to be around here for the duration of the conference till the end tomorrow and a little bit after. So if you have any questions, feel free to flag me down. First of all, a little bit of background. The reason why we're seeing some of these issues come up, there are 3 issues. Number 1 is heightened monitoring and testing globally. Number 2 is the development of new national MRLs, so some countries are developing their own rather than going with the international system. And 3, our Codex system, which is an international MRL system, is behind schedule, which is why a lot of countries are looking at Codex and saying we're getting so far behind, we think we're just going to develop our own national system. And some countries are going ahead and doing this. So these are the 3 issues that form the background. First of all, in terms of heightened monitoring and testing, we know that some importing countries are testing more often. We also know that the cost of testing has gone down, and we have simpler and more sensitive testing methods. So if something's simpler and it's more sensitive and it's less costly, then you're obviously going to use the tool more. And we're seeing a lot of this happening. So how sensitive are analytical methods? Well, MRLs typically are measured in parts per million. And a part per million is 1 minute in every 2 years, or 1 cent in $10,000. So a part per million isn't very much. New analytical methods that we have out there are measuring pesticides in parts per billion. So just as an example, a part per billion is 1 pinch of salt in a 9 metric ton bag of potato chips. So if you consume salt at this quantity, you'd probably never have a problem with hypertension in your life. Your doctor would be really happy. I was just curious about what a 9 metric ton bag of potato chips would look like. So I scaled it up and superimposed it on a map of southern Alberta. So this 9 metric ton bag is 28 kilometers across. And inside that bag of potato chips is 1 pinch of salt. So this gives you an idea. So when you have 1 part per million of pesticide residue in the crop that you take off your field, this is what you're dealing with. Now there are 2 reasons why methods have become more sensitive and why they're more accurate. The first one, the acronym is QUECHERS, and the second one, lots of letters, TQGC MSMS. First of all, QUECHERS is pretty straightforward. There's a new method for pulling the sample out of a cargo or out of a bag and analyzing it. And QUECHERS just stands for quick, easy, cheap, effective, rugged, and safe. That's how the sample's prepared. The next one is a piece of equipment called a triple quadrupole gas chromatograph, which is coupled with a tandem mass spectrometer, or a tandem mass spec. I'll give you an idea what these look like. Here's QUECHERS. You take the sample and you prepare it, and your crop goes into one of these little blue bottles. This whole apparatus is about the size of a tabletop. It's about 8 feet long, about 8 feet tall, 4 feet deep. And you can see there's probably hundreds of samples sitting on this tabletop that are being analyzed for residues. Once the crop's been prepared using quetchers, it goes into this machine. And your sample goes into one of these little bottles up on top. That's the gas chromatograph to the left and the mass spec on the right. These sit on a tabletop. We could have this whole apparatus sitting on your tabletop, and this will analyze pesticide residues down to a part per billion. So if you're an analytical chemist, this is vroom vroom. This is great technology that's coming their way. We used to look at a project management triangle, which has fast, cheap, and good on the corners, and everybody knew if you had fast and cheap, you got an inferior product. If you wanted it good and fast, it would be expensive, and if you wanted it good and cheap, it would be slow. Now with quetchers, some of us, which is the analytical chemists, can now have it all. So this might not mean too much to you as a producer, so I've translated this into farm language. This is a 760 horsepower, 16-cylinder Detroit diesel engine tractor. It has a 1,000-gallon fuel tank and it weighs in at 100,000 pounds. It's quick, it's easy to use, it's effective, rugged, and safe, so we have fast and good. If we had cheap on the same scale that the analytical chemists have with quetchers and the new machinery they're dealing with, this would be delivered to your farm for $85,000. Then you would have it all as well. Quick, easy, cheap, effective, rugged, and safe. This is just an example of a rice cargo. And a rice cargo, or this could be a wheat cargo, pulls up into a port somewhere in the world. Before that cargo is unloaded, somebody will take a sample from that cargo load. And that could be a 60,000 metric ton cargo load. So these are pretty big boats. They'll pull samples out of that cargo, they'll run it through quetchers, they'll run it through the gas chromatograph, they'll run it through a tandem mass spec, and before that cargo is unloaded, this is the sample that comes out. Up at the top, left, you see the number 1, and 260 pesticides have been analyzed in that sample of rice at less than a part per billion. And this will happen before that cargo is even unloaded. This is a really quick method. It's very effective, it's very sensitive. So if there is anything in the crop on that cargo, someone's going to pick it up at the destination. The second thing I talked about was we had the development of new national MRLs. So rather than using Codex, which has been the accepted international system, countries are now developing their own international or their own national standards. So what we're finding is that this is being run by health authorities. They have no mandate for and no knowledge of trade, but they tend to be the decision-making authorities. So what's happening is that they're making decisions that are inadvertently setting up major barriers to trade. The Codex system, as I mentioned, it's behind schedule. There are massive delays in active ingredient reviews within this system. It takes years to get something through Codex. You actually have to schedule review. Every country of the world gets into the Codex process. In Canada, every year the federal government goes out to producer organizations and asks for which products they want to move forward, which active ingredients they want to move forward on which crops. So this is an annual process, but there are delays. So we've had countries like South Korea, Taiwan, Hong Kong, China. They've all developed Codex. They've dropped Codex and they've decided to develop their own national system. The United Arab Emirates, Mexico, and India, we've heard, are moving in the same direction. What happens when you develop your own national system is that the tolerances become unknown. So you'll end up with active ingredient X, and the country will develop an MRL, or they may not develop an MRL. A lot of times there is no MRL in a country, so you end up with a blank. You just don't know what it is. Codex filled in some of those national blanks, and we had something to go on. But with countries going away from Codex and to their own system, we just end up with this big unknown where we don't know what the tolerance is going to be once we export to that destination. In Canada now, we're starting to see a lot more awareness in the food value chain, and that includes producers, primary and value-added processors, wholesale and retail distributors, consumers, governments, non-government organizations, and regulators. We know we have a need for guidance. We know that we have destination market testing, but it does depend on the type of crop, and it also depends on the active. Some active ingredients are being flagged, and others aren't. Now, this system isn't new to horticulture. In the horticultural sector, you have a small number of growers. They've been well established for years. The value chains understand the issues with MRLs, and they're moving high-value produce into high-sensitivity markets. So as an example, this is an MRL chart for a blueberry producer in Oregon. And down the left-hand side, you have the chemical name, the active ingredient, and the product name. And then you have the export destination and the MRL in that destination. So this is for the US. So the first column you're going to see, the first small column is USA. Next to that is Canada. You can go down that list, and wherever you see a gray box, that's either an unknown tolerance. So the US has a tolerance set for a product in blueberries, but Canada has no tolerance level set. Or the tolerance in Canada is lower than it is in the US. And this is where it's an issue, because if that blueberry came to Canada and Canada analyzed that specific blueberry for the residue, and that residue was higher than allowed in Canada, it would be flagged and that cargo could be rejected. So even though the MRL in the US is being met, if the MRL in the importing country is lower and they test and it's above what's allowed, then that gets flagged and it could be rejected. So if you're an Oregon blueberry grower, you pretty much have to know where your blueberries are going to go before the season starts. Then you have to run down this list, and depending where you're going to export your blueberries to, you decide which products you're going to use to manage the pests in your crop. Now, this is new to bulk grains. So Canada exports to 72 jurisdictions. This isn't necessarily new for crops like pulses. With pulses, we only export to mostly 15 countries, but we're exporting 5 different pulse crops. So 5 times 15 is 75, so we're still dealing with 75 different export situations as opposed to the 72 export destinations that we are with wheat. And if we look at these countries that we're exporting to, there's a wide range of countries that take a different type of pulse crop. So for example, the EU takes a huge proportion of our beans. 37% of our beans are exported to the EU. But if we're looking at something like peas, 42% go to India, and proportionally less go to the EU. So there are some countries or some jurisdictions where we have to look at the MRL before we export, and we have to be careful about that. So in pulses, we have been dealing with this to a certain extent. With small grains, we haven't. With horticultural crops like blueberries, cherries is another one, or potatoes, they've been dealing with this for years, and they've been managing the situation. Now here with pulse crops, we're looking at desiccants in pulse crops, and I'm sure a lot of you are familiar with this chart. If you're going to use a desiccant in a pulse crop, Pulse Canada has put out this document, and it identifies the desiccant that you could use, and it identifies the jurisdiction that you're exporting to. If you see a yellow caution triangle in the box, that means there could be an issue using that desiccant on that crop if you're going to export to a specific destination. If there's a green check mark, you're okay. So you can go through this list of desiccants. This list could be expanded out to include a number of different pesticides that are used on the farm in pulse crops. Canola has also dealt with this through the Keep It Clean program. If you go onto their website, there are some guidance documents that help explain MRLs and how to get your canola ready for export. So industry is developing some of the tools that you might need on your farm, and some crops are dealing with this very well already. So has this happened before? Yes, in the US in 2004 we had an issue with dry beans. In 2011 we had an issue in the EU with lentils. In Canada, the MRL for glyphosate or Roundup on lentils is 4 parts per million. In the US it's 8, so it's double our level, which is good. The EU had no level set at all, so they deferred to their default, which was 0.01 parts per million instead of our 4 or the US's 8. That caused the issue. Lentil movement from Canada ceased into the EU at that point. This year, we had an issue with Japan where canola treated with Clever or quinclorac was refused acceptance by a number of grain companies because they just thought the risk of segregation for a $1.2 billion market was too high, and they weren't going to deal with it. We also saw in 2015 wheat treated with the plant growth regulator manipulator, or chlormequat chloride. Ultimately, some of it was segregated by the grain handlers, but originally they weren't going to accept it because the US wheat market is worth $0.8 billion and they thought the risk was too high. So initially they were refusing to accept it, and we still have an issue of producers having to sign declarations as to what was used on their wheat crops. Now, these two products in particular, I'm just referring to these as orphan chemistries. Chlormequat chloride has been around for a long time. It was discovered in the 1950s. BASF has patents that date from 1975. It's manufactured by 19 companies in China and 16 in India, and it's entered the Canadian market as a harvest management tool, and a lot of people are using it and they think that's really valuable. Quinclorac, or Clever, was initially developed for control of propanil or stampede-resistant barnyard grass in rice. It was in development in the US in 1988 for rice. It was registered in sorghum in the US in 1999. It was developed by BASF for cleavers control in canola in 2000, but with the merger of BASF and product rationalization, some products fell off the product portfolio, so quinclorac was left behind, and it wasn't developed. In 2014, or 14 years later, it was registered as Clever for cleavers control in canola, so it came back, but it's not a new product. So I refer to these as orphan chemistries. Now, this is actually a good thing because we added tools to the crop protection toolbox. So as producers, there was one more pest management tool that came into your toolbox, 2 in these instances. Unfortunately, the onus in 2015 was on you to ensure that the MRLs were in place in all potential export destinations all over the world for your wheat and canola. And in my opinion, that was an unfortunate situation. Now, why do the exporters fear a rejected cargo? There are direct costs and indirect costs. If we look at direct costs, transportation charges, the shipment may need to be destroyed. There are a number of things that are happening, but if a bulk vessel of 60,000 metric tons is rejected, we're looking at a multi-million-dollar cost to the exporter. Intangible costs, then we need segregation programs. We need to develop testing tools. We need to keep the producers informed. And there are ensuing consequences. And by consequences, I mean once a cargo has been flagged as having an MRL breach in destination country, you risk losing that country as an export destination. Even if you don't, the export destination will enhance their testing for your crop. And one example might be Japan. You export something to Japan and you get flagged with an MRL issue, they will increase the testing. They will increase the testing for the specific exporter. The exporter is at risk of losing an export license, so the costs are really high. And then there's the damage to the Canadian reputation. There are a couple places you can play a role. Dis-harmonization isn't one of them. This is just an issue we have with jurisdictions all over the world having different MRLs than ours. We just don't have that harmonization. There's not a lot you can do directly as a producer. But when we do end up with a situation, one thing I wanted to point out, if you look at this chart down at the bottom, we have the green triangle, which is Zone 1. And this is MRL compliance, legal for trade, and safe for human health. Zone 2 is still safe for human health. And an example is the 8 part per million MRL for glyphosate in lentils in the US. It's 4 in Canada. The EU set it at a default of 0.01. That doesn't make it unsafe for human health. It's still safe, but it automatically becomes not legal for trade, and you fit into Zone 2. So it's a trade technicality, not a health issue. This is a work in progress. I just wanted to let you know that there are a number of people working on this. The Industry Government Task Force on MRLs has been active for 3 years now. It's being led by Gord Kurbis at Pulse Canada. It's really improving the reach of the growers into some of the people that deal with trade internationally. So the growers are being represented in Ottawa with the Market Access Secretariat and the Trade Secretariat. So there's a lot of discussion going on there. The producers are seeing a lot of potential to influence and guide government agencies, and they are becoming key influencers. So there are good things happening in this area. We've run a number of projects where we've developed MRL guidance databases. We've completed these for beans, blueberries, chickpeas, cherries, faba beans, lentils, peas, potatoes, soybeans, and wheat in Canada. And this is the part of the project that I'm working on specifically, is developing tables like we see for the Oregon blueberry growers. These are also available in Canada for some groups, for some commodity groups, including blueberries, cherries, and potatoes. But I think what we need is a basis for understanding. What do we know? Where do we start? What are the facts? What can we do? What cannot be done? And what needs to be done? I think we know that the economic impact is substantial. We can't segregate crops. It's not practical. As producers, you don't know where your crop is going to go for export when you're seeding it or spraying it. We don't have the ability to trace back. MRL trade issues are really important, but we are sharing information. We're developing these relationships. I think ultimately, as producers, you need to enter into some discussion with your producer groups and make sure that your interests are represented. If there are issues in the field, then you need to contact your producer group and let them know that there are issues out there that you would like to have addressed. And I think at that, you really need to take the bull by the horns and take action. It's not, I don't think that the producers are in a position where they just have to sit back and let all this happen. I think you need to let your concerns be known. Thank you.